In this video, we're going to discuss outliers, and we're going to discuss the modified box plot. So outliers and the modified box plot. Well, outliers are numbers that don't really appear to even be coming from the same population, right? That they're very different than the rest of the sample. And outliers can have a dramatic effect on a lot of different statistics. In particular, we've talked about already the effect of outliers on the mean, the standard deviation, and the range. Okay, so in this video, we're going to discuss how do you identify an outlier, and then we're going to discuss how to make the box plot slightly different so that it notes the outlier. All right. So I have the ages of 8 randomly selected individuals in a clothing store. Okay, so this looks like a clothing store for relatively young people. First thing I want to do is find the 5-number summary. Then I want to identify any outliers. So we're going to do this mathematically. Okay, so not just by looking at it, but we're actually going to calculate if any of the observations are outliers. And then we're going to construct this thing called the modified box plot. So in the previous video, we discussed regular box plot. This one is going to be modified, meaning it's kind of like a box plot that takes into consideration outliers. Okay. So let's start with the 5-number summary. 5-number summary is the min, the first quartile, the second quartile, the third quartile, and the max. So the min and the max are the easiest to fill out. This data has already been sorted, so usually the first step would be to sort your data from smallest to largest, but this data is already in order. So the smallest observation is 5, and the largest is 50. Okay. Now let's go ahead and calculate the quartiles. To calculate the quartiles, I'm going to use this equation. K over 1,000 times n, right? This is the equation that's helpful when you're trying to find percentiles, right? So K is the percentile, n is the sample size, L is the location of that percentile. So starting with the first quartile, that's the 25th percentile, so K is 25. L is 25 divided by 100 times 8, right? Okay, so that basically comes out to 0.25 times 8, which is 2. Right, remember, when L turns out to be a whole number, we need to take the average of 2 and 3 of the second and third observation. All right, so the second and third observation says the average between 12 and 6. All right, so the average between 12 and 6. So that would be, go ahead and add up 12 and 6 and then divide it by 2. So that's 18 divided by 2, which is 9. Okay, so the first quartile is 9. Now let's go ahead and find the second quartile. So now L is 50 over 100 times 8. So that's 0.5 times 8, which is 4. Again, this is a whole number, so I need to average the 4th and the 5th observation. So here's the 4th, here's the 5th. So average up 13 plus 15 divided by 2. So that's 28 divided by 2, which is 14. So second quartile is 14. All right. Lastly, let's calculate the third quartile. So that's the 75th percentile, so 75 divided by 100 times 8, which is going to be 6. Okay, since that's a whole number again, we're going to need to average the 6th and the 7th observation. So 6 and 7th, that's average 18 and 22. So 18 plus 22 divided by 2, let's see, that's going to be 40 divided by 2, which is 20. All right, so now I have my 5-number summary. Okay, so now how am I going to identify any outliers? This is the new piece of information we need. To identify outliers, what we do is we create a lower and upper bound, and then we say, okay, so if you're outside of those lower and upper bounds of the usual sort of numbers, then you are an outlier. Okay, so let's talk about how to calculate the lower and upper bound. So the lower bound, LB, is the first quartile minus 1.5 times the inner quartile range. And the upper bound, okay, is often written as UB, is the third quartile plus 1.5 times the inner quartile range, right? So you go down to the first quartile, and then you go minus a little bit further, and then you go up to the third quartile and plus a little bit more. Okay? All right, so we need to know how to calculate this inner quartile range. That was in a previous video, IQR. Remember, this is the third quartile minus the first. So let's go ahead and start calculating that for this data set. That would be third quartile is 20 minus the first, which is 9. So that comes out to be 11. All right. So let's go ahead and calculate our, oops, let me go ahead and fix that. Let's go ahead and calculate our lower bound for this data. So that would be the first quartile, which is 9, minus 1.5 times the inner quartile range, which is 11. All right, so that comes out to be 9 minus 16.5, which is negative 7.5. So that's the lower bound of our non-outlier observations. All right, then let's calculate the upper bound. This would be the third quartile, which was 20, plus 1.5 times the inner quartile range. So that's 20 plus 16.5. Okay, so that comes out to be 36.5. Right, so non-outliers, non-outliers are in the range negative 7.5 to 36.5. Okay, so non-outliers are in this range. So do we have any observations that are not in that range and therefore are outliers? Right? Yeah, we have this 50. 50 is outside of this upper bound, right? So the person who is 50 is an outlier. Okay, so that's how you identify outliers. You calculate your upper and lower bound, and then you see if there are any observations that are outside of those bounds. All right, so lastly, now let's make our modified box plot. So first step in a box plot is do your x-axis. This stays the same. So down here we have the age of people in the store, in the store. Okay, and we're going to go ahead and start at 0. Let's see, I'll count by tens. So 10, 20, 30, 40, 50. Okay, and then I'm going to have vertical lines for where each of my 5 numbers are in my 5-number summary. So the min was at 5. The first quartile was at 9. So that would be here, right about there. Second quartile was at 14. So you center around right here. The third quartile is at 20. Okay, this is what's different. So this makes up your box. Now the max is at 50, right? But we've determined 50 is an outlier. So we don't put the max there. That's what's different about a modified box plot compared to a normal box plot. Usually we would just put a line at 50 and then we connect it, and then we'd have our box plot, right? So since 50 is an outlier, I'm just going to put a dot there instead. Then I'm going to put with the max at where the max of the data is, that doesn't include the outliers. Okay, so let's go back to our data set. Let's look at this. So the next highest number, which would be 22. So this becomes our new max if you were to exclude this outlier, right? So 22. So that's where I'm going to put my line for the max up here at 22. Right? So there we go. So we have this dot. That's where the outlier is, and then the next closest observation that is not an outlier, that's where you put your, that's where you put your new max. All right, so there you go. This is a modified box plot.